so wrong page. This is my website, and it's called brainsize.weebly.com. And for my Passion Time project in my class, my question was, how do the brains of modern humans, primates, and other forms of life that lead up to us today differ? As you can see, it says life equals brain equals heart equals life. Without your brain, your heart would not know to pump, so your body would not have oxygen. Yeah, so your brain is kind of in charge, and your heart just does the work. Thank you for visiting my website and watching the video. Share anything that you think is interesting to your friends. There are a lot of big words in this paragraph right here about EQ, but as you can see, I'll just highlight what it means, like what EQ stands for, or like same thing. I'm not going to say it out loud. There's a link for cognition, which is right to Wiki. It's cognition is like the intelligence, kind of. How it relates to my project, EQ is basically an assumption of the animal's brain size, which is supposed to be a rough estimate of the intelligence of the animal. So, it's kind of an estimate. The EQ is an estimate. More interesting stuff. EQ has a high degree of correlation with ecological conditions of an animal, such as its feeding behaviors and food it consumes. There's so many big words. Okay, so yeah, I'm comparing different animals with humans and stuff. So, fish brains. Fish typically have quite small brains relative to body size compared with other vertebrates, typically 1/15 the brain mass of a similarly sized bird or mammal. Yeah, so translating, it means most fish brains are small for the size of their body. That little paragraph right there is from Wiki, and I translate it if you didn't get anything. Chimpanzee brains. This paragraph, because I'm probably going to say some words wrong, there's a lot of big ones in there, but what it's saying is that chimpanzees are very sophisticated and smart. They use different hunting strategies, and they have status and rank, and they can even understand aspects of human language and different number sequences, numerical sequences and stuff. So chimpanzees make tools and use them to acquire foods for social displays. They have sophisticated hunting strategies requiring cooperation, influence, and rank. They are status conscious, manipulative, and capable of deception. They can learn to use symbols and understand aspects of human language, including some relational syntax. I can't say that. Concepts of number and numerical sentence. They are capable of spontaneously planning for a future state or event. Yeah, pretty like humans, just a little less sophisticated. We're very close with chimpanzees in our brain and stuff. They're very smart, very fun. Okay, human. Now let's learn about the human brain, because we're comparing that with other animals. Bigger brain. Let's get a neurosurgeon. Does a bigger brain make you smarter? Click the button for a cool article about the human brain. This is from Stanford University. If you click that, then it will take you to a whole website from where you're at, where somebody asks a neurosurgeon, does a bigger brain make you smarter? I'm gonna do that so nobody can spoil. Oh, whatever. Here, you can't. You can still see the answer, but I'll read the highlight of the answer. Okay, so despite the uncertain relationship between brain size and cognitive abilities between different species, can brain size predict anything about intelligence amongst humans? Does having a gigantic brain mean you're smarter? As cartoons like Pinky and the Brain and Jimmy Neutron Boy Genius would have us believe? So, yeah, as you might have seen, some studies claim the answer is yes. Maybe bigger brain makes you smarter. Okay. Now, a little more about the human brain. This is a link to Wiki about the human brain, but I did a little bit. I'm mainly just giving links to Wiki because I've read paragraphs and paragraphs of all these categories and learned a lot. I obviously didn't memorize it, but I got the main idea and more. My project is covering a lot with lots of different animals in the human brain, so just a little info in here and a link to a great source. The human brain is the major organ of our nervous system. It has the same general structure as the brains of other mammals, but with a more developed cerebral cortex. Yeah, there's a link there also, and then this is to the human brain. Okay? So, we learned main organ. So, we've learned a little bit about human brain. Not really, but Pictures. Here we go. Pictures. Pictures are a great source to this information because, as you can see, chimp brain is slightly smaller than a human brain. If this was 1 centimeter, you could see how they'd be close. Yeah, a little bigger brain, a little smarter. It's good. Here, if these were rough estimates of the brain size, this would be like the animals. These are different types of like monkeys. A gibbon's a monkey. Then orangutan, gorilla, chimpanzee. Now this is just a model, just a picture of the brain. It's not really about brain size comparison, but it's just like showing you where the brain's at. It's just a picture of the brain. So my notes. Okay. My website is basically all my notes. Everything that's on my website is what I learned. Here. You can't really see it over the play button, but Passion Time notes. Humans have more intelligence than other animals. That was like a picture. If this was a human brain, that'd be a mouse brain, that'd be a fly brain. Animals slightly bigger than humans sometimes have smaller brains, like chimpanzees or gorillas. Okay, fish brains. We already read that on fish because that's where it's on paper. Okay, take a second. That's what I already read. Yeah, small fish have small brains for the body size usually. Okay, this is interesting about the human brain. The max weight of a female brain is usually between the ages of 16 to 18. The max weight of a male brain is usually between the ages of 19 and 21. There's a cool website right there. Yeah, that's what I just said again. Oh, male brains tend to weigh more than female brains. The adult human brain weighs an average of about 1.5 kilograms. Okay, my sources. If it would load. Here we go. Sources. I used Wikipedia a ton. Even if not everything on there is true, to learn a lot, go to Wikipedia. Google Images, you can see some of them of the photos and pictures. Yeah, I showed you pictures. There were even more pictures, but I couldn't fit them all on. And some of them, they didn't show up good and they didn't look good on there, but images help a lot. Now, differences. Now the main part of, I think chimpanzees are close relatives. We're close relatives with chimpanzees. We think alike in some ways, both make tools. Humans and chimps both have ranks, yet we control and use them differently. The male leader will lead the tribe of chimps, and the president will lead the whole country. Yeah, so you can see how human and fish differences. Fish have small brains for their bodies, and humans don't. Humans and fish use their brains for different things. Fish use it to survive and find food, while humans use it to go to school and the grocery store for food. Fish have lots of predators, and humans have none. Different situations give different priorities. Yeah, that's like the main difference between humans and other life forms leading up to us today. Back at my essential question. How do the brains of modern humans, primates, and other forms of life that lead up to us today differ? The main way is the situation. Now more. Buttons. This is just a button for wiki brain size. I actually have a brain size page. EQ is very complicated. Back to that EQ. Brain size comparison. Or whatever. Big words. Oh, there's even a link for wiki from that. EQ. Basically, the main thing to learn about for my essential question. Wiki has some great pages about all of this, but most likely written in Martian. So read the first paragraph and understand as much as you can. Thank you, and goodbye.